Hello, I'm Mrs. J, and today we're going to go over limits. When you're finding limits with a graph, this says the limit of f of x as x approaches -2. So you want to look where x is -2. Remember, this is the x-axis, and this is y. So when x is -2, we're here. Look at both sides, the y value are coming into the same value, 3. From the right and from the left, we're going into the same value. So our answer is 3. If we look at this one, we're looking at x approaching 0. So x is 0 here. Notice over here it's coming in at 1, and over here it's coming in at 0. So that means the limit as x approaches 0, plus sign means from the right, it's coming in this way. Think of the right side of 0, or a little bit larger. It's coming in at 1. The limit as x approaches 0 from the left means on the left side, so we're over here, it's coming in at 0. If these two are not equal, the limit as x approaches 0 does not exist. So these two have to be equal. If they are equal, then just like this one, the limit from the right would be 3, the limit from the left is 3, therefore the limit at it would be 3. But this one would not exist. Let's look at a couple more. So if we look, notice it's discontinuous at 3 because there's a break. So it's discontinuous at 3. The limit as x approaches 3 from the right, if you want, you can think of drawing a dotted line on your x value. And we're looking, plus means on the right. So you're looking on the right side of the dotted line. And our graph is here at 4. Limit as x approaches 3 from the left, we're on this side, and the graph is approaching -2. So you're looking for the point, depending on which side you're on. On the right, the graph's here, so we're using 4. And on the left, the graph's down here, and we're using -2. Since these two are not equal, the limit as x approaches 3 does not exist. A lot of times they'll also ask for f of 3. The way we have it right now, notice there's no shaded in point. And so this would not exist. But if there is a shaded in point, right here, then it would be, in this case, 1. So you're looking for the shaded in point when it's written like this. And if they're all open circles, then that does not exist. In this case, I shaded in one, so it's this one. No. Okay. If we have this, not only was it discontinuous at 3, because of this open circle, because we jump here, it's also discontinuous at -1. Move this over here first. So we'll find the limit as x approaches -1 from the right, from the left, and at the value. Again, you can draw a dotted line. The limit at -1 from the right, we'd go on the right side of the line, and the graph's over here. And the point then would be -4. On this side from the left, you go on the left side of the line, over here, and again, notice they're both coming in together. So it is also -4. This one, notice they came in at different spots. These are coming in together. All 4 are going to be the same answer. So if these two are equal, this one also is equal. Now if we look at the point, f of -1, there's no shaded in point, so this does not exist. Use the graph to find the following limits of function values. And we're saying when a is 0, notice it's 0. The two are coming in together at different values. So it says the limit as x approaches 0 from the left. So for here, the left means a little smaller. It would be over here. And we're here at 1. The limit of 0 from the right, on the right side of the axis, is over here, and it's a -2. So that means the limit is 0. These two are not equal, so this one doesn't exist. Now f of 0 is looking for a shaded in point. Is there a point where x is 0? No, there isn't. So that means it's undefined. It doesn't exist. Well, I guess we'll do it. Notice this one is a solid line. It's talking about -2. So it's right here. -2. Trying to get the whole thing in there. So it says limit of x as x approaches -2 from the left. -2 is here. So from the left would be here, and we're coming in at 2. Move it up here. Notice how it's all coming in together. They're all going to be the same, whereas these two came in different. And that's where we have the different values. The limit as x approaches -2 from the right is this side. -2 is this side. But it's also at 2. That means the limit as x approaches -2, since these two are equal, this one is the same. Last one, f of -2. That's looking for the shaded in point, and this is one solid line, so the point is at -2, 2. So when it's a solid line like that, they are all going to be the same. Okay, limits to infinity. When you're looking at a graph, this one's saying the limit as x approaches negative infinity. X going negative infinity is going this way, so the graph is going up. It's going to, well, you don't have to put the plus sign for positive. It's positive infinity. If we were looking at the limit as x approaches infinity, we would be going this way. And as x is getting larger, y is getting close to 2 1/4. Give it one more. Okay, so if we look at the limit as x approaches infinity, we're going this way because x is getting positively large, and as x gets positively large, y is approaching, and this is a 3. Because it's getting close to, but it will not cross the horizontal asymptote. If we look at the limit as x approaches negative infinity, that means x is getting negatively large. We're going this way. Y is going down. Since it's going down, it would be negative infinity. Sorry. Alexa, dismiss. Alexa, dismiss.